Take a look at exponent rules again today to kind of summarize them. In class we're going to go over these notes, but then I'm going to give you some common errors, and working in teams you're going to find how you can prove that these are in fact errors and how you can simplify them correctly. So let's look at some of the rules from yesterday. Multiplying with the same base. If you forget any of these rules, you can expand it and write it out. D to the fourth means 4 D's times d to the fifth, which is 5 of them. And so if you count how many d's there are, this is d to the ninth. So you learn that if something has the same base and they're being multiplied, you can add the exponents. So this would be x to the 11 plus 8 is 19. This one right here, if there's more than one base, we have to multiply them together. So this is 3 times 2. There are a number of bases, so that's our 6. And then we have 1a here, and we have 4 a's here, so we add them together, and 1 plus 4 is 5. So we have a to the 5th power. And let's take a look at our b's. We have 2 here and 5 here, so this would be b to the 7th. So there would be our answer right here. We looked at dividing. Again, if you forget any of these rules, expand it and simplify. So let's say we forgot what g to the 7th divided by g squared is. That would be 7 g's on top. It would be 2 g's on the bottom. And think about canceling. You can cancel 1 g on the top with 1 on the bottom. And so it looks like we have 5 g's left on the top, so this is g to the 5th. And the rule is you subtract the exponents if they have the same base and they're being divided. So this is g to the 7 minus 2, which is g to the 5th. All right, so let's use that rule here and just look at the different bases. There's x first. There's 3 on the top and 1 on the bottom. So when you simplify left, there's 1 on the top. There's 4 y's on the top and 5 on the bottom. So when you cross off, there's 1 left on the bottom. The next one, let's just do our numbers individually. So let's do our numbers first. 10 and 15, let's reduce that. 10 divided by 15. Well, we can divide each of those by 5, and so that would be 2/3. Let's look at the x's. There's 2 on the top and 8 on the bottom, so when you cancel them, 2 from the top and 2 from the bottom, there's 6 left on the bottom. And then with our y's right here, we have 7 on the top, 1 on the bottom, so we have 6 left when we cancel. So here's what our answer looks like. And my workspace quit, so let me restart. Equivalent negative exponents. So we went over that rule. If they have the same base and they're being subtracted, you can subtract. So this is the same as k to the negative 4th. But we learned from crossing off that this is the same as 1 over k to the 4th. So if it's a negative exponent, you can make it positive by flipping it to the opposite spot. If it's in the numerator, flip it to the denominator. If it's negative in the denominator, flip it to the numerator. So let's take a look at this one right here. This would be x to the 3 minus 1, which is x squared. And this would be y to the 4 minus 5, which is negative 1. But we know that when we cancel, this is the same as x squared over, and there'd be 1y left on the bottom. So here's how we're going to write it. The next one, again, we have 10 over 15, and that is the same. I think we did this one before where we divide, and we have 2 over 3 when we divide each of those by 5. And then we have x to the negative 6, y to the 6th, but we know from the previous example that we get 2/3. There's 6 y's and x's on the bottom when we cancel, so here flip the x to the 6th on the bottom, and this is y to the 6th. A power to a power, again, if you forget, write it out. This is d to the 4th, but it's 3 times. So then if we add these up, we get d to the 12th. So the shortcut was you multiply these together. 4 times 3 is 12. So this one we're going to multiply and distribute. This will be a to the 66th, b to the 42nd. This last one, distribute the 5 to all the bases. So we have 3 to the 5th, a to the 5th, b to the 20th. And then we can actually take 3 to the 5th power, which is 243. So here's our final answer, 243, a to the 5th, b to the 20th. And then to the power of 0 we looked at yesterday as well. Show why x to the 0 power equals 1. So I'm going to use the rule where if we have, let's say, x to the 6th over x to the 6th, if we have the same base, we subtract the exponents. So this is x to the 0. But what is any number divided by itself? That's 1. So if we skip right from this step to this step, we've shown that x to the 0 equals 1. because it's really from taking any number dividing by itself. So in class, what we look at is common mistakes. So I'll do an example if maybe we would work here. Okay, so it says identify the mistakes, correct, and justify and show your reasoning. So for example, this first one, 2 to the 5th does not equal 10. So you'd show why this means 5 factors of 2. And this does not equal 10. It equals 2 times 2 is 4, times 2 is 8, times 2 is 16, so this is 32. So in class, we're going to look at all these cases and show why the following are all incorrect. And that will be part of your assignment as well.